Okay, so this is 3.3. Again, we're still working on probability. So based off of yesterday's lesson, we had you guys roll a couple dice. In fact, it was 40 times. And it was to figure out exactly how many times a certain number occurred. And a couple of big things we were going to talk about. We know that rolling a dice, especially a d6, you have 1 out of 6 chances. Which really turns out to be about roughly 17% chance of occurring. What we really want to talk about is how many trials should you run? Because even with just 40, some of you might have some interesting data where you'll have a couple of numbers that are higher than others, when realistically, based on a prediction of 17%, is they should be pretty even across the board. The issue with probability is it is all based off of how often you perform the trial. If I only roll the dice 4 times, in fact, I do it a few more times, I will see some issues occurring, where sometimes you'll get some skewed data where you've got one peak where you shouldn't have. If you only roll the dice 7 times, you're going to see issues like this. Even 40 times isn't necessarily enough. If you had rolled it 100 times, and again, kind of the rule of averages is the more you do, that's when you start to see this probability become closer and closer. And again, this goes back to like the coin flipping rule. In theory, if I flip a coin, I have a 50% chance of getting heads or tails. If I flip the coin twice, I should get a heads and a tails just by number of odds. But there is a chance I get a heads and a heads. If I flip this coin 10 times, I should get 5 heads, 5 tails, but there's still a possibility of getting, 10 heads and no tails. So you want to make sure that you reproduce and test your probability as many times as you can. So the more trials you have, the better. And we're not talking like 10 trials, we're talking like 100, 1,000, even 10,000 trials. So the more you get done, the closer you're going to get to your actual probability. When it comes to probability, your two options, when you add up your 2 or more probabilities or your outcomes, you should always equal up to 1. So when I look at flipping a coin, I get an options of heads or tails. If I roll heads, I get a 1.5 chance. If I roll tails, it's a 1.5 chance. So it's 50 and 50. If I add those together, I get 2 out of 2 or 100%. You're always going to have 100% as your probability of one of these 2 options, because that's the only thing that can happen. Same when it comes to rolling dice. I can roll a 1 through 6, and each of these numbers has a 1 in 6 chance. When I add these all up, I have a 6 out of 6 or 100%, because I'm guaranteed when I roll this dice, I have to get one of these numbers. I'm not going to roll a 7, because it doesn't, it's not on this dice. So when you add up all your possibilities or your probabilities of all the possible outcomes, it has to equal 100%. If it doesn't, you've messed up your math somewhere. Now, for this next example, we're actually going to use a d20, which is basically, we have a d6, which has got 6 sides, and we have a d20, which has got 20 sides. There are 2 types of d20s that I have in my possession. I've got what's called a randomized, where basically the polar opposite number is on the bottom. So you got 20 and 1, you'd have 19, and you'd have 2, and everything is kind of backwards. There's also what's called spin down dice. These are often used in more games where it goes 20, 19, 18, 17, 16, and you basically use this, often is used for life counters and whatnot, where this technically, as far as if I'm going to roll this dice, they both have the exact same odds of rolling, let's say, a 20 or a 1. Because even though this one is quote-unquote randomized in its positions, and this is a spin down, the fact that when I roll this dice, it still has the same chance of rolling a 20. If we have 20 numbers, and we're trying to roll, let's say we're trying to roll a 20, okay? If you're playing D&D or some games where you're trying to hit something, 20s are nice, we like them. So you're trying to roll a 20 on this dice. 20 is one of our 20 faces, or rather it's 5%. So when I roll this, I got a 5% chance of hitting my magical 20. If I roll a d6, and again, I'm trying to roll a 1, because there's only 6 possibilities, it's a 1 in 6, so there's a 16% chance. So when it comes to rolling dice, I'm far more likely to roll a 1 on a d6 than I am to roll even a 1 on a d20, just because there's so many more options. If I put it back on a probability line, which we went over in the very first section, probability line again, 0 is there's no chance, 1 being 100% chance, 50% is kind of that 50-50 mark. Proving I have a better roll, or a better chance of rolling a 1 on a d6, because I know it's 16%, which is roughly about here, versus rolling a 20 on a d20, which is a 5% chance, which would actually be probably closer to here. So I can kind of visualize and put on my line graph here, or my probability line, what the different odds are for each of those rolls. If we want to increase our outcomes, so let's say we're not going to restrict ourselves for our d20 of just rolling a 20. What if I can also roll, or let's say if I'm looking for, if I can roll a 3 or a 7 or a 12, right? Out of all my possible options, 3, 7, or 12 is great. Now I've got 3 numbers out of this d20 that would suffice or work. So now it's 3 divided by 20, which is now 15%. So it's not the exact same, but it's certainly close. I can roll a 3, a 7, or a 12 on a d20 and have almost the exact same odds of rolling a 1 on a d6. Again, looking back at our formula for this, is your probability is equal to the number of outcomes you're looking for, or to satisfy your requirements. In our case, 3, 7, and 12, there's 3 of them, versus the total number of outcomes. So, your first question for this is you're going to be given a d20 dice, or you've got one. If you roll this d20 dice, what are the odds of you rolling a 1, or a 3, or a 6, or a 19? I want you to tell me the odds as a fraction as well as a percentage, please. The second question has nothing to do with dice, but we're going to look at it this way. If I had a bag of marbles, in my bag of marbles I have 4 white marbles, I have 5 pink marbles, and I have 3 blue marbles. What are the odds of pulling out 1 blue marble? If you have any questions, I'm available on Tuesday and Thursday. Other than that, good luck.